Wow, seconds early. I don't know if I can start seconds early. All right, welcome everybody. This title implies that you're at Mac admins, and this is about like Docker workflows that you use to admin Macs. Just to clarify as we start, because I had someone ask me about that. So let me get started and jump right in. There's a lot of info. Don't worry, I've provided most of it to you in writing. So who am I? I started in computers when I was about 3 on dumb terminals. I've been with Playbill in New York City for about the past 12 years. I spent 15 years as a professional stage manager, kind of in the middle of my computer consulting and computer work. I've been consulting. I started my first consulting company when I was 16 out of my house. And I've been an Apple fan since my first Apple II Plus. Actually, it was an Apple II, then an Apple II Plus. But it was the Darth Vader edition, which I was talking with Justin about earlier, which was all black and had Bell and Howell plastered all over it. For some reason, Apple permitted that. If you want to catch me in Mac Admin Slack, I'm at Porthos John. I can't get rid of the pirate roots from the 80s. Sorry. Just very quickly about Playbill. Playbill's been around since 1884. Next year, we're celebrating our 140th anniversary. We are the authoritative magazine and program for Broadway and other theaters around the country. We have 4 major online web properties. We have 3 offices, including a travel office with about 100 Macs and as few window machines as I can possibly be prevented from throwing out the window. And as all of you, we have an understaffed IT department, so we're always looking for creative solutions that might take a little bit more on the setup end, but then make your life easier on the day-to-day. And to answer the question that everyone asks me, no, I don't get free tickets to Broadway shows. I have to pay for them just like you. On this, feel free, I'll leave the QR up for a second. I've posted a GitHub. It has all of the code files that I'm deploying, just the kind of hello world. It also has some step-by-step walkthroughs of stuff I'm going to cover, just in simple Markdown. Feel free to message me about it. I'll be updating it for the benefit of Mac admins and when they post the video to make sure that anything I missed before I talked and went, oh, I should have noted that, will get into that repo by the time they post videos. What you should walk away with today, a basic understanding of what CICD is, because everybody loves to use the term. It's continuous or continuing integration and continuous deployment. They are 2 separate things. They often get merged. I'll get into that in a second. You'll have a runbook for my way, at least, to deploy Docker-based apps to AWS in a continuous way via GitHub, so that all you have to do is make a commit, it redeploys it, and your app is live for all of the people you need to service. Some security stuff I'll go over about how to keep those apps private. One of the reasons that I use AWS is because it's easy to integrate SSO and SAML into the system so that people can't even access the app to try to log in unless they're part of your SSO system and authorized. And lastly, a list of gotchas that will prevent you from spending hours with a duck, because it's very easy when you're dealing with the AWS stack to get bogged down in troubleshooting and going over various things. The software, this list looks daunting. Some of it is just suggested. Some of it is just good idea for every day. For your Mac apps, the only thing you need to make this happen is Docker Desktop and an IDE. Recommended would be a clipboard manager, because clipboard history is something everybody needs. And you're going to be copy and pasting 8 things, and it's easier to copy them all than go into the app and paste them all. DDEV, which is installed via Homebrew. If you do any type of CMS-based web app, be it with WordPress, Craft, Joomla, Drupal, any of those, DDEV is a local environment that will automatically spin up local servicing, including a local database for your CMS. It takes about a minute and a half to set up a local dev environment. All of the more expensive IDEs are DDEV aware, as are some of the free ones. iTerm, which is just a replacement for the Mac terminal because I prefer it. Do it whether you like it or don't do it. The AWS CLI, their command line interface, can also be installed via Homebrew. It will make your life easier. I highly recommend it. The rest of the stuff, GitHub, Docker Hub Online, you have to have accounts there, even if they're free accounts. AWS resources, I'll be going through. This is just a list for future reference. And then, the last two things I forgot to take out. 2 necessary hardware pieces, a duck, and this is my damn it doll. If you tend to get really frustrated and don't want to hit things, this is designed to take all the beating you can give it. And it's a voodoo doll that you can tell, you can name it AWS, you can name it your app, whatever you want, and then you can beat it until you feel better. And then you can go to your duck and explain what's going on. That's all the resources. There will be other things, you'll hear it. Throughout this presentation, I will try to jump to some live things in the AWS console, as well as locally on my Mac. I've done most of these steps in advance. If I have time towards the end and anybody wants to see a step-by-step on 1 or 2 pieces, I can try to do that. But I'm trying to impart a lot of information without overwhelming. So it's all here in the slides. It's all in the GitHub repo. Feel free. Jumping right in, GitHub Setup. Public or private repo, doesn't matter, except to you, I'm sure. Set up at least 2 branches when you start. You don't have to use 2 branches, but I recommend setting up at least 2. And here's a convention I'll be using throughout the presentation. The little key are just tips and tricks that I've discovered make your life better because they prevent you from making mistakes. And that is, on your main branch in GitHub, set up branch protection. All it means is it keeps you from committing to the branch or merging to the branch without at least reminding you that you should have someone review your code. If you're the owner of it, you can bypass the protection, but it makes you check a box and really think about it before you do it. Highly, highly recommended. Docker and Docker Desktop. Set up a Docker Hub ID, free one, and then locally you're going to need to pull a generic image. Doesn't matter what it is. It just we need something to populate into AWS. There's probably a way around that. I haven't found it yet. I haven't wanted to spend the time on it yet. So you just pull something local so you can tag it and push it. Again, a note with a clipboard manager, put your credentials in it as you do all of these things, because you're going to come to steps later where you're going to need it again, and you're going to go sifting through all the apps where you take notes trying to figure out what you did. The key point here is the reason for the Docker Hub is that when you're pulling images, when you're layering your application together in a Docker image, you're pulling 15, 20, 100, 150 different Docker Hub resources that you're going to need. And you're pulling it all from the same IP. Docker, when you don't log in, has a rate limit, and it can shut you down. Having a free account lifts the rate limit much, much higher. I've never run into a problem since I did that. So I just recommend just have the account, and you'll see later in the specs where you put that login to make sure you don't hit that rate limit. Setup and structure, this is just how you set up your project when you're programming it. These are my recommendations. Do whatever works for you. I keep an infrastructure directory that is just notes. It's all full of markdown files. You'll see that in my GitHub repo. It allows me to quickly jot down stuff so that I don't forget it, or make a step-by-step if I have to make a change to one of my standard run books. I'll note the exception in that. I use a note-taking app called Obsidian, which does everything in Markdown anyway, so I can just pull those files and dump them straight in. Have a Docker directory, obviously, with all your Docker files, but not your Docker Compose file. I'll get to that in a second. Have a deploy directory that's solely dealing with your files that AWS is going to need that you're going to want to reference. And then if it's a web app, have an HTML directory. Everything for your web app should be in there. The Docker Compose files being at the root makes it easier for you to keep generic code when it comes to the pipeline that we're going to create, and you'll see why later. If you're using DDEV and a CMS software, the HTML directory is important because what you don't want to do is end up deploying things that might be in your Docker files or in your deploy directory out to the eventual application. So if you make sure that you just know anything in the HTML directory will end up on that web server, then you can comfortably put things outside of it. I still wouldn't put credentials in there because it's going to GitHub. But otherwise, at least you can keep some form of mystery as to how you do stuff in the background. Gotchas and considerations. There are a bunch of these. The first thing to consider when you're doing something like this is whether you want to include the code for your web app, your Python app, whatever it is you're doing, within the Docker container itself. You don't have to, because you can export a volume and mount it, and then you can instantly change your code without having to redeploy or do anything like that. It makes your code a lot less portable. If you have to build it every time, if it suddenly moves from an ARM machine or a Mac ARM machine to an Intel machine, then the CICD pipeline is going to recompile it for anything that you're pulling in, composer packages, anything like that will get redone for the environment and the processor that you're using. So I recommend it, plus volume dismounts, and the biggest thing, file permissions. If you're mounting directories, you're subject to the file permissions of the host machine instead of the file permissions that are automatically set within your Docker container, so you don't have to think about it. Pick x86 or ARM early on in your process when you're doing this. I recommend ARM because it's cheaper. The servers are cheaper on AWS. Even at the micro level where you're paying like a half a penny an hour for a server, it's still cheaper by 0.2 of a penny or whatever it is. Utilize notes and secure storage locally to make sure you don't lose credentials. AWS, for instance, you create an API key. They give you a single download of a CSV that has the key and the secret, and that's the only time you ever get to see the secret again. So if you don't store it properly, you're going to have to deprecate it, figure out everywhere you used it, and create a new one. Last thing is, and this is just throughout AWS, tag, tag, tag. They offer free-form dictionary tagging on every resource. It helps you search things up. It helps you group together things, especially for billing, if you have to answer to your finance department as to what does this application cost us every month. You can very quickly bring up reports based on those tags. Okay, that's a lot of talk and nothing about the topic. One last gotcha that has cost me dozens of hours of troubleshooting time. Generative AI is brilliant, especially when writing code. It is not brilliant for things like, how do I do something in Amazon? How do I do something in Docker? How do I do something on GitHub? The interface has changed too much. Generative AI is not updated often enough on those things, and it speaks with a super authoritative voice that says, this is the way you do it. And you'll spend an hour trying to make it do it that way, and it doesn't work. And then you go in and say, but this option doesn't exist. And it says, oh, I'm sorry, how about this way? And that way doesn't work either. And you say that doesn't work, and it says, oh, I'm sorry, how about this way? Which was the first way that you tried to do it for the last hour. So stay away from AI for step-by-steps. Stack Exchange is still your friend there. Okay, so AWS setup is actually really easy. You get initially set up, and you get what they call their root user, which is like the root user on a Linux system. Toss that out the window very, very quickly and put second factor on it, because it's the only thing that always has access to everything you do. And create a user for yourself in what they call IAM, which is Identity Access Management for them. Set up an API key on that user so that you can use the command line on your Mac locally, because there are some things that, believe it or not, Amazon will update and make work, but they forget to put a checkbox in the GUI. So you can do it from the command line, but until they remember to add it, it's not in the GUI. So just always keep AWS command line in your back pocket. If you install it, type AWS configure. It'll ask you for your key, your secret, what region you normally use, and then you have access to everything in your AWS account. And do that from an administrator user for you only. Otherwise, whoever you give it to has access to everything in your account. Keep your tabs open with your AWS services. There are times where you're going to be like, oh, I forgot my naming convention and I need to look that up. Switch to the tab, because if you click on it, it'll take you away from that page and you'll lose all the setup work you've already done in that one. This is a key point and a duck point and a frustration point. IAM is probably the worst service you will ever use with Amazon Web Services. You will spend hours trying to figure it out. If you try to manually write in their security language, you will pull your hair out strand by strand trying to figure it out. But once it's set up, once you understand it, it's fairly solid. But their security language has its own rules, has its own indent policies, its own bracket policies, its own comma policies, and they're not consistent. So try to use the automated GUI generator as much as you possibly can. Where you can't, look it up on Stack Exchange. It's the only way. It will never work from ChatGPT or Google Bard. It just won't work. Write up your tagging strategy. Put it in a note. Before you start creating resources, know all the keys and values that you're going to want to put in so that you can get back to it later. I use everything from just naming projects to naming environments to we use tags for a partner that we have with AWS to mark resources that we want them to monitor and how often they should be monitoring them and how key they are and if they're critical and how critical of the notification that you send to us is. Those tags can be used throughout the system, and they're really powerful and super useful. The first thing that you'll need to set up in AWS is the secret manager. This is my particular way of storing everything that might even possibly be sensitive and anything you want to put in environment files if you're serving for a CMS or something that uses an env file that's hidden at each server level and that's different for your local machine and your server. This is what Secrets Manager looks like. Oops, sorry, need my glasses to be able to read. Of course, if it ever comes up. We'll just go this way. So you can have as many secret stores as you want. They charge you by the access. I think it's a thousandth of a penny for every 1,000 requests to pull up the authentication credentials. So everything adds up with AWS. You eventually pay a bill, but it's usually pretty small, at least to start. I won't show you the Docker Hub because that has real credentials in it, but I can show you, for instance, the demo build. One of the things you can do with this is if you put credentials in your secrets, they'll be automatically pulled in the pipelines that you're creating, but your individual developers won't have access to the credentials. You don't need to spread them around. You don't need to send them in a Slack note and then worry about who had access to it. So if you use secrets, you can keep things centralized. You can also use secrets across different projects and applications. One Docker Hub account is all you need. Use it everywhere. That's what I do. And then you can look at it. The nice thing is you can actually retrieve it in plain text. You can look at it as key value pairs. You can look at it as a straight up JSON, and you can edit it as a straight up JSON. And if you need to copy, they don't have a clone function, but if you need to copy, just select the entire JSON string, paste it into the new secret you're creating. That's all it's the quickest and easiest way to keep track of that information. You can keep un-GitHubbed files local if you want on your machine. Just don't include them in your repo that have the JSON strings for everything, all your secrets that you need for that particular project, so that you can recreate it quickly. If you're not using your own credentials, if you're using, for instance, RDS, which is Amazon's database service, you can automatically rotate root credentials on whatever schedule you or your organization requires, so that root credentials are always, you can always go in here and pull them up and look at them, but they get rotated at the server on an automated basis. One thing, because I use this, one thing to note is that you have to, it's not built into the process that you're going to use secrets, so you have to set up what's called an IAM role or permission policy that allows your apps to read the secrets. Everything is IAM in AWS. Everything goes through it, down to the finest grain permission. And there might be 5 different types of read permissions. I try to shortcut sometimes. I know I shouldn't. I just grant, all read access and then move on, because I don't want to sit there and figure it out. If it's your account, there's not a lot of danger on that, because the roles can only be used from inside your account. So, as I said, we create secret stores. You can use the secrets cross-project. For your project-specific stuff, what I recommend is at least 2. One is the build necessary stuff that could be for all your environments, and then one is for your actual ENV that's specific to different environments, be it dev, staging, UAT, production, whatever it is. And that way you can very quickly figure out what's where, and when you need to make changes, you can change it and you can re-release it like that onto your systems. As I said, go through JSON for speed and copying, and we talked about the root keys. The next piece to configure is the Elastic Container Registry. That's Amazon's Docker Hub. It's not as ubiquitous. It does offer public. It doesn't charge you for private. I create an ECR entry, a record, for every single container that my application uses. It keeps it cleaner. It means that I've got a record of the exact container that was last deployed to every single one of my apps. Let's see if this one actually comes up. Yes. So this is the demo one. You'll see there's just two containers listed. One of the nice things is after you create it, if you remember I said when you install Docker Hub on your desktop, Docker desktop, you're going to want to just pull down something like Nginx or something like that to prime the repo. When you get the repo, you can go into it, you can view the push commands, and you can literally copy and paste those to your Amazon CLI, the command line, in your terminal, on your machine, and it will push whatever you tag. So I usually skip the second, and I don't build an initial. I just, like I said, use a generic like an Nginx and a version number. Tag it, push it, move to the next one. And then just keep going through that until I've primed every one of those repos. Elastic Beanstalk. This is the second worst service to use on Amazon. It's touchy, but it's touchy for reasons that I'll make clear, and that's why most of these are caveats, tips, or tricks. Elastic Beanstalk launches EC2, which is container instances, into Amazon Web Services. Elastic Beanstalk will manage it, it will monitor it, it will deploy additional servers based on whatever metrics you set up and tell it you want it to deploy on, up to a maximum level, down to a minimum level. It'll scale up and down automatically within your environment. Ideally, once you create an Elastic Beanstalk environment for whatever applications you need to use, you won't ever have to touch it again. That's the ideal piece. I have in the GitHub repo, I have the step-by-step on each setup page of how you should, what I recommend you set up. Don't ever skip my runbook or your runbook. You will forget a single option, and there are a number of options in AWS throughout the system where if you don't do it at creation time, you can't change it later. So just keep that as a caveat and make sure you're aware of it. Roles and networks, all of that stuff, again, that's all noted. I don't want to get into too many weeds here. It's not a workshop. Roles and networks are the most common trip points. So permissions through IAM, and then the security groups and permissions of all of the networking, in and out, who's allowed to access your resources, all of that. Pre-set up your virtual private networking center. Is that what VPC stands for? I can't remember. Or use the default. If you're going to have a lot of different things in there, set up multiple VPCs. That's up to you. I leave that to you. Subnets inside of your VPC, deciding which, like US East 1 for Amazon has 6 availability zones. When they offer a new type of server, that server may only be available in 2 or 3 of them. So include as many as you can when you design your network so that you make sure that if you want to take advantage of the latest and greatest, you can. I talked about some of the optional services. I'll leave this as a reference slide for everybody. There's a lot of other services you can configure alongside Beanstalk. I'm going to go straight into building a pipeline. I'm going to pause for a second because I've been talking for too long. Are there any questions up to this point? I'm just going to show the next stage is really to just show you how to take a repo and get it out there and get it up. So important in this is code deploy, which takes a simple YAML. Can you read that? Probably not. Oh well, it's in the repo. But it's a YAML that tells the system how to deploy it. Take mine, steal it, feel free. It's all just basic. At the top, I pull all my secrets, declare all my variables. We then install, in the install phase, I'm pulling down whatever containers already exist so we don't have to rebuild them. Then you have a pre-build section where you can pull containers, and then you have your build where you're building everything, and that can include all the Docker files you want with all the build commands. You can install Python, you can do any of it all directly from there. I even take my Docker compose file because I don't like rewriting it twice. I don't like maintaining 2 of them, and I automatically strip out all the build section in the Docker compose, and then I copy it to an artifact that'll deploy so that if I crash my server, if I crash my Docker containers, I can get out there and I can bring them back up without rebuilding the application. It takes 3 seconds to access them in and bring your Docker containers back up. Because everybody has those moments. The nice thing about their YAML in build spec is that they do permit comments. YAML doesn't usually. Their version of YAML does. So please comment your code because you will need to remember it. Let's see, covered all that, covered all that. Okay, so I'm gonna skip over to live web here. I'm just gonna keep, because I can't keep the notes up at the same time I'm not in the presentation. But if you look right now, I've got an Elastic Beanstalk application, Mac Admin's demo, that then, hang on, let me make this a little bigger. There we go. And you'll note that when I created Elastic Beanstalk, I did 3 of them. I intentionally broke the first one, just so that you can see it's very easy. It works, it serves. The whole reason that that says red is because I unchecked one option about, I didn't want to use enhanced health. I just wanted to use basic. And because enhanced health isn't enabled, it failed because it has to be disabled in 2 places. So those are the kind of options you can run into that can screw you up. But as I said, that environment is working. If I go here and I click to the environment, oh, of course, Safari, you hate me. Yeah, it's not gonna let me. Nope. All right. I will open a different browser in a second. But so creating these environments, I'm just going to run through it really fast just so you can see. There's only a few options, but the nice thing is you choose your platform, you say Docker, and it builds everything. It manages everything for you. You don't have to build the operating system environment. You don't have to preload Docker. You don't have to update Docker. You don't have to do any of that work. It does it for you. So if you're running Kubernetes servers in your environment, you can run them up here. I usually stick to the rule of if you think you need Kubernetes, you don't. You have to know you need it before you jump into it because it's overcomplicated. Amazon has their version of it. Everybody has their own version of those orchestration tools. Stick with the basics until you know you need it, and then you can orchestrate the deployment of it because it takes a lot more work than I think you could cover even in a workshop session here at Mac Admins. That's one of the reasons I use AWS is because they manage a lot of the infrastructure layer for you if you want them to. You don't have to. You could actually go with a one-page configuration here with a single instance, direct contact, no load balancer, no nothing, and I could have it launched in, I think it takes about 30 seconds to launch the environment. When you configure a load balancer and all the other things, it takes you a few more minutes. It takes about 4 minutes to launch the environment. It's really not that long in the grand scheme of things because you can move on and do the next steps while it's launching. And then come back and figure out what you screwed up and see all the error messages. Okay, so I'm sorry, I lose my place occasionally. In code pipeline, this is where you can build magic deployments. So I've built 2 just to show you. So let's see, I forget what I called them. There, and of course it went away. So that is the one that's deploying the GitHub repo right now. I have another one that's in the stub state of, I usually configure my my Elastic Beanstalk environments first, so I don't even have a code base yet. So I just put their demo app on there, and I have one that'll show you that, and I'll do that in a few minutes. But basically, when you go to create a pipeline, all you're looking at is this. You name a pipeline. Call it whatever you're going to call it. Doesn't matter. Again, you hit these service roles. In this case, you can allow it to just do its thing. A lot of the advanced stuff, you're not even going to want to look at it, let alone mess with it. Oh, that's right. Because depending on the service, it decides whether or not it wants to let you use spaces. So it starts in the source stage. All you do, I have GitHub set up. I select GitHub. I'm connected. I pick my repo. And then I pick my branch. That's all it needs. This is a key one. If you have this checked every single time you deploy, every single time you commit, you merge, you do anything to the code base, it'll start deploying to your server. And it will, if you do 2 commits within 30 seconds, it'll start the pipeline and it'll start the pipeline again. And it'll deploy once right on top of the next one, which could be bad, but usually isn't. Then you move straight on to the build stage. Use AWS Code Build. This is a lot of options. This is create a project. This is what you need to do throughout. But with your build project, again, a lot of simple options. Tags you can add. You do a managed image. This is some of the stuff you have to be careful of. Operating system, Linux 2 is easy. Runtime standard, there aren't many options. Now you get to your image. You see a big number and you're like, oh, I always want to use the latest. You have to look back here and see that the latest ARM build is actually 3.0. The latest x86 is 5.0. So you don't always jump to the latest with Amazon. Always be sure, because if your build environment doesn't match your Elastic Beanstalk environment, if one's ARM and one's x86, something's going to build wrong at some point. I guarantee it. And you're going to tear your hair out trying to figure out why it won't build. And it's just this innocuous error message that you'll never figure out, because some package that is a dependency on a package that is a dependency on a package has built for x86. And you're trying to run it on an ARM server. Again, I'm just trying to give you the caveats. This is one of those checkboxes. This one right here, privileged. When you're building a code pipeline, if you do not check this, you cannot go back and change it. If you're doing Docker, you have to check this, or it can't build the containers because it can't get sudo access at the root of your thing. Everything else, you just leave as it is. Once you've built it, and Amazon decides to be connected, it's immediately available as a project. I can add environment variables here. I don't need to, because within the project, I skipped over it, but you just put in your deploy directory. It's in my notes. You'll see it. That pulls in all of your stuff. The last stage is the deploy. With Elastic Beanstalk, you can just go in, choose the app name, choose the environment, and that's it. The instant you create this, it will start deploying to your environment. So, quickly, to just show you one of the things that we can do in the pipelines, we're going to look at this one. So you'll see it sitting there waiting. It tells me what the last thing I did was. I'm going to go in and I'm going to edit the source stage, and I'm going to turn on start on source code change. Save it, now I'm going to go over to my repo here, and I'm going to go into index, and I'm just going to say and I'm going to commit it. I'm going to push it. Oh, what did I do wrong? I changed the README file. There it goes. And you'll note, by the time I can get back to my web browser, it's already started deployment. I'll let this run through while we talk, but basically, if I can type. We've got it without the changes right now. Those are deploying in the background. So I'm going to stop talking for a second and let people ask any questions they've got. Is there anything right now? Sorry if I'm talking too much.
I got a question for you.
Yeah. Hold on.
In that scenario where we did the deploy, what does the approvals process look like?
The approval process is controlled at GitHub.
Okay.
So basically, if you protect the branch, if you make it so people can't make a commit or can't make a merge on the branch that it's active on, then it won't go. You can make it so that they have to have console access, like I showed you here on this page. When I'm looking at, where was it? Here's the pipeline. If I What is going on with Safari right now? Really hates me. Code pipeline. So if you look at the pipeline, it's going to tell you all the time that it's in progress. You can always manually release a change right here, whether or not it's a new commit, whether or not you've got the auto commit, you can always force it to release a change. If any stage fails, you can retry directly at that stage. So you don't have to do a pull from the GitHub repo. If your Elastic Beanstalk environment dies for some reason, you don't have to rebuild the entire thing. You can just do a re-release at the repo level. So as that goes, you'll see it go. It'll run through. If you want to see things, you can always go in and look at, or you can't. I think it's too many tabs open. Nope, it just hates me. I have no idea why it likes the single page, but it does. If you go in and look, this is everything in my Docker files is getting built. I have a stub of a PHP container in here because I didn't have a chance to strip down my Docker file, so it's building a lot of things into PHP that are unnecessary for what we're serving here, which is why this is so long, because it's installing things like ImageMagick that this one-page app will never use. But the real key here is that you can take anything that's being deployed in any of these steps and get it out quickly. So I have, I couldn't even count the number of, and I'm actually going to skip by this for a second. We'll come back to it in a sec. But there are so many use cases that we've found for it inside of our organization. Things like, I have an email signature generator. Now, it's not something you'd want to make available to the public in general, but I want everyone in the company to have access to it. It's a 2-page app, little web app. All it does is has people fill out their information when they click next. It flips to a page where it generates their email signature so it's consistent across the company. It uses a CDN-based image for our company logo so that people aren't attaching pictures to every email they send, which we've all received those with like the 4 or 5 different attachments, which are especially nasty when you're looking for that email that had an attachment you needed. That's a very simple use case. We also, I've automated workflows for MDM enrollment through Docker containers, and we were running them on local servers and paying the VMware tax, to keep different slice servers running and having to maintain those servers as well. It's all moved into the cloud. Everything's attached to our SSO logins. We use one login in the house, and I can connect that via OIDC to Amazon load balancers. As I said at the beginning, you can protect any resource behind your own SSO and keep Amazon out of it. And they don't care. So really, where am I? I got too far back. All right. And it really lets you know on and on. Let's see if this finished. So you can take anything you do in a Docker container and deploy it. And if you want to pull a specific Docker container, just build that, put it in your Docker hub. Pull it. You don't even have to build it. You don't need a code build phase except for pushing the Docker container out in an artifact. That's all you need. And this looks like it is done. That succeeded. And now you can see it's at Elastic Beanstalk. And of course, it's not going to show me that. And that's the code that we changed and deployed. Apparently cache clear is my friend. Sometimes. Just tips and tricks as you hit the end of it, and I'm actually done a lot earlier. I can do any walkthroughs if anybody wants to see anything specific. If you can't find the answer quickly while you're doing this, it's probably IAM. It's probably, well, I should also say security groups between your environments. It's one or the other because they're very specific and very granular, and you just have to pay attention to it. If you spend more than 5 minutes troubleshooting Elastic Beanstalk or code pipeline, destroy your environment and start again. Because you made some error that it's going to take you much longer to track down than it will to go through a runbook that takes 3 minutes to recreate your environment. Nothing should be destructive in there because everything should be in your GitHub and in your secrets. So recreating the environment costs you nothing but a couple extra minutes of time. I got trapped on this one so many times I can't tell you. Why do I still see that red X on health? Why won't it work? Why won't it work? I'm going to try to fix this. It's going to work. No, I'm going to end up terminating the environment because I forgot to check a box like privileged that now suddenly it can't deploy, and it's going to give me the error message every time. When you do load balancers, there is an option for shared or dedicated. I highly recommend dedicated because AWS sets everything up for you and you don't have to worry about it. When you do a dedicated load balancer, you can use AWS's certificate manager. You can get free certificates just like you can through any of the number of services that now you have to install for. AWS will do it all automatically. You can do your SSL at the load balancer. You never have to touch it in your Nginx, your Apache setup, whatever you're doing. You don't have to worry about deploying certificates to your instances because they're quite honestly inaccessible unless you're inside of your console or your environment. This is something that takes a little while to remember. If you use AWS already and you start using automated deployments, don't ever try to stop the instances directly, because the automated systems will go, oh, that server stopped, and it'll spin up another one. And it'll spin up another one, and another one, and another one. Every time you terminate and stop, it'll spin up another one. I just talked about the load balancer. There is one fairly new permission with AWS, and it's called SSM. And it will save you time in the sense that you don't have to worry about access groups to be able to SSH into your instance to check Docker, check what's running, check what's not. Because you can, with SSM, I can go into the console, go into the list of my servers, and say, connect to this one. And it pops up a web window with a terminal session directly at the root account of that EC2 instance. So you have direct access to the entire instance with no restrictions without having to figure out permissions from your not caring if you have a terminal app. You can do it from an iPad. It doesn't matter. There's no SSH session. It's done through your SSL on the web. And that's really about it. Do we have questions?
I just got one more question about that SSM thing you just mentioned. Does that also apply to other cloud services, like with RDS?
No, because you never have root access to RDS ever. But EC2, if you look, I put that permission onto all of my things. Yep, I got you in back. If you look, I can check off a running server. I click connect. It fills out all the information. I click connect. This screen is supposed to be black. Except not for this long. And there it is. And now I'm at the command line, and I can do a Docker PS, shows me everything that's running. I can go var app current, and in there you'll see the Docker compose file. So I can restart my Docker containers. I can go in and take a look at, I can connect to the Docker containers. Anything I need to do, I can do directly from the command line within that console.
For the runbooks that you were talking about, are you using anything like Ansible or Terraform?
You can, setting up the environments through Terraform can be done. My problem with using something like Terraform is that it's incredibly structured and incredibly cemented. I prefer to keep a runbook and create my environments every time I do them, because AWS changes their options so often. They will support what came before for a period of time, but they have a very hard and fast life cycle on all of their services. When they release version 4, version 3 is deprecated 3 months from today. And if you need it longer than that, you actually have to ask them for a special dispensation, and they'll enable your account to use it longer, but they won't let you go that much longer.
Okay.
So it's one of those things. I had that problem with an RDS server where we were trying to get to Aurora, and they were deprecating the minor version of MySQL, and I couldn't move to Aurora yet because Aurora didn't support the minor version I was on. And I was like, you forced me to upgrade, I'll never be able, because you're not keeping Aurora up to date. And they said, okay, we'll extend your life on that version. In fact, we'll extend everyone's lives on that version until we bring Aurora up to speed. I apparently was not the only person who talked to them about that. Anyone else? Questions? Points? Your experience? Let me ask, in general, are people using a lot of Docker containers in your workflows at your offices? Is that something you've worked in, or are you just using a lot of Python?
A lot of people are just Wild West locally on their systems and need to gather up like a DevOps initiative and deliver that to them. So it's
Yeah, a lot of Wild West. That was what the comment was.
And that's because of the Mac, really. Like on the Windows side, it's being managed. It's just like they've just forgotten the Mac people, and they just do it.
Yeah, there's a lot of, just to repeat the question since we don't have the box up here, or the point, there's a lot of Wild West because a lot of the Mac people aren't supported on some of these legacy DevOps systems that have been put in place. So there's a lot of Docker that ends up serving out, from people's individual machines even, and they end up on the network, and it can be a nightmare and a disaster. So the more you can centralize those and pull those things off of individual computers, the less you have to worry about the network security of preventing people from serving that themselves.
At my previous workplace, we did, one of my coworkers used Docker extensively for the web app for the college that we had before we moved over to a more centralized like CMS. And they also started playing with Kubernetes, like you were saying. They're like, oh, maybe we need it, maybe we don't. We ended up not needing it. So yeah, I get what you're saying.
Yeah, don't ever use an orchestration tool. They bill them as, this is an amazing thing. It'll take care of all of your Docker needs and all your Docker problems. And yeah, it will after you spend 80 hours training on how to use it. And those 80 hours would have been spent much better somewhere else. Because once you start using it, you realize, well, Docker Compose does that. Like, I don't really need Kubernetes to do that. Docker Compose, for those of you that don't know it, is a light orchestration agent that basically tells Docker how to use the Docker files. It's almost like Terraform combined with Docker. Just tells it how to build the environments. Justin, you want to toss in the box?
So not trying to play devil's advocate. I have a team of 8. We have DevOps engineers. We actually inherited a Kubernetes on-prem system at Penn State, hosting our enterprise applications for accounts management. So for enterprise level applications where you need high availability and scaling, it works well. But it's not for the faint of heart. It does take a lot of training, and you have to really, really want to invest in it. So both skill sets have to be there, and it takes time to get there. And we're in the process of right now trying to reduce the amount of time spent maintaining our on-prem instance, which is maintaining the OS layer, the container versions, all the operators within, secrets management, all of that. It's a lot of work for the team. The team is brilliant, and they're excellent, and they're skilled. But we are in the process of moving most, if not all, of the workflows that we have in there to EKS, because then we do less management, but we still gain the benefits of Kubernetes, where it is highly available and scalable.
Yeah.
So at home, I'm running containers for 3D printers. Okay, that's easy, right? And I use Docker Compose there too, because hey, great, it automatically starts. That's my home toy stuff. But for larger applications like enterprise level, where we need high availability, scaling up and down, it does work very well. But it feels like it's very much in the infancy, like VMware was, right? And then VMs obviously took off, and that's a thing. This, to me, is just another abstraction, and I'm sure I'm not the only one saying it, is another abstraction of running applications at a higher level, because VMware has Tanzu, a lot of different companies are saying, hey, come and buy our thing, we'll manage your container workflows in Kubernetes. And it's kind of the wild west right now, and running plain vanilla Kubernetes is not for the faint of heart, so I think it's still in its infancy, but it has a lot of potential.
It does have potential. It needs management tools that are available to the average DevOps person, rather than requiring the training levels that it requires specifically for that now. Because, as you said, you have to want it. You have to need it. And you're going to have to see a benefit from it from a team of 12 or 15 people that are moving in and out of it, and your application. I will say we run our main website, which averages 6 DB servers in a cluster, and usually 8 to 12 webheads on a daily basis, sometimes scaling up as far as 20 or 25. We manage that without Kubernetes. We're just scaling it in EC2. It's using basically the same workflows I just showed you today. it deals with it. The scaling services are getting better just in native Amazon. That has always been a problem up until a couple of years ago, was that they'd say, oh, yeah, put your database in here because we can auto scale it to 15 servers with 25 shards and all of this beautiful stuff, until you find out that it takes a half hour of overuse before it says, oh, I should probably spin up another server. And then it has to pull it in from a backup and an image, and it has to pull it out. And by the time it upscales, your traffic load is gone, or your website's down. That's gotten much better. They now have they have a serverless database service, which can run anywhere from, like, I think it's 1 to, or now it's 0.5 to 200 virtual CPUs, and it will scale within 30 seconds. It'll scale up in under 5 seconds, but it will scale up once in under 5 seconds. The second scale could take 10 minutes. So you have to be very careful about the way you control these services. And it's the same thing with Kubernetes that I found, is that if you set the initial scaling wrong, its response time to that second scaling event, because it realized it didn't spin up enough, will be a problem. And that's one of the reasons we've stayed away from it, is because we have a finer grained control over the scaling operations with just Docker and Docker Compose.
Yeah, I'd say keep it as simple as you can. If the services work for you, there's no need, and you have to weigh your cost and benefits. Absolutely.
Yeah.
It depends on your scenario. Yep. Yep.
Anybody else? Anyone? 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 I can give you back 15 minutes of your life. Of my life. I'll take it. Thanks, everybody.